Okay, so here we have a chemical equilibrium question. 5 moles of ethanol, and we're only going to do part 1 to D. We're not going to do part E. 5 moles of ethanol, 5 moles of ethanoic acid, 6 moles of ethyl ethanoate, 4 moles of water were mixed together in a stoppered bottle at 15 degrees. After equilibrium had been attained, the bottle was found to contain 4 moles of ethanoic acid. Write an equation for the reaction between ethanol and ethanoic acid to form those two things. So that's the first thing we're going to do is write that equation. Right. So your ethanol is C2H5OH and your ethanoic acid CH3COOH. And since this is equilibrium, we use those arrows to produce CH3COO, C2H5 plus water. So, right. So then that's our equation 1 to 1 to 1 to 1. So part B, write an expression for the equilibrium constant Kc. So your Kc is going to be equal to, and I'm going to shorten the formula for the ester to RCOOR, concentration of that times the concentration of water divided by the concentration of the acid, which I'm going to put as RCOOH, times the concentration of ethanol, ROH. Okay, so that would be our equilibrium expression. Then now it says how many moles of ethanol, ethyl ethanoate, and water are present in the equilibrium mixture. Right, so what they told us about the equilibrium is that 4 moles of ethanoic acid is present. And so what we can do here is rewrite ROH plus RCOOH, right? And reversibly produce RCOOR plus water, right? This is a 1 to 1 to 1 to 1 ratio. And what we're going to do is use our ICE, the initial amounts, the change which occurs, and then the equilibrium amounts. So initially we had, let's double check, we had 5 moles of ethanol, 6 moles of ethanoic acid, and 6,4. So 5 moles of ethanol, 6 moles of the acid, 6 moles of this, and 4 moles of that. So let's triple check. Yes, 6 moles of ethyl ethanoate and 4 moles of water. So there you go. And then they said at equilibrium you had 4 moles of this. Now, if it is that you have 4 moles of acid at equilibrium, it must mean that 2 moles must have reacted. So we can say that's minus 2. Now, the ratio of ethanoic acid to alcohol is 1 to 1. So if 2 moles of acid reacted, then 2 moles of ethanol will also react. Now, based on that, if 2 moles of acid reacted, then 2 moles of ester would be formed. So this would be plus 2. And again, since it's 1 to 1, that's also plus 2. So at equilibrium, what we now have is 5 minus 2, which is 3. 6 plus 2 is 8. And then 4 plus 2 is 6. Right, so now that would be the equilibrium amounts. When it says how many moles of ethyl ethanoate, ethanol and water are present in the equilibrium mixture. We just did that. So now we can work out for part D what is the value of Kc for this reaction. So that's what we're going to do now. Our Kc would be equal to the concentration of the acid, of the ester, which is 8, times the concentration of water, which is 6, divided by the concentration of the acid at equilibrium, which is 4, times the concentration of the alcohol, which is that. And this now becomes simple stuff. 8 times 6 is 48, divided by 4 times 3, which is 12. So that's equal to 48 divided by 12. And that's equal to 4. So our equilibrium constant here is 4. And since it's 4, it tells you that the amount of product is 4 times the amount of reactants. So therefore, this equilibrium lies far to the right, because 4 is pretty much a very big number in this context. And so there you have it, just working out the value of Kc and what it means for a given example. I hope this was helpful. All the best.